What if AI could design the very chips that power AI and do it in half the time at a quarter of the cost? That's not a hypothetical. A startup called Cognichip just raised $60 million to make it happen, and Intel's CEO is betting his name on it. Here's what you need to know. On April 1, 2026, Cognichip announced a $60 million Series A led by Seligman Ventures. That brings total funding to $93 million since the company was founded in 2024. The headline investor? Lip Bhutan, CEO of Intel, who is personally joining Cognichip's board. So is Umesh Padval, managing partner at Seligman. Existing backers Mayfield, Lux Capital, FPV, and Candu Ventures all increase their positions. When every seed investor doubles down, that tells you something. So what does Cognichip actually do? Think of chip design as the construction blueprint for a skyscraper, except this skyscraper has 104 billion rooms, which is roughly how many transistors sit inside NVIDIA's latest Blackwell GPU. Drawing that blueprint today takes hundreds of engineers, 2 to 5 years, and anywhere from $150 million to $500 million at advanced process nodes. By the time a chip reaches production, the market may have already moved on. Cognichip wants to compress that entire cycle using a physics-informed AI foundation model it calls ACI, Artificial Chip Intelligence. Unlike bolting a general-purpose large language model onto an engineering workflow, ACI integrates physical constraints, circuit behavior, and manufacturing realities directly into the model. It reasons across digital, analog, and mixed signal domains simultaneously, replacing the traditional step-by-step sequential process with parallel exploration of design decisions. The company claims this can cut development costs by more than 75% and slash timelines by more than half. Now here's where it gets interesting for you. If those numbers hold up even partially, 3 things change in the real world. First, custom silicon becomes accessible to smaller companies. Right now, designing a cutting-edge chip is a game only hyperscalers and the largest semiconductor firms can afford. Drop the cost below $40 million and compress the timeline to 12 to 18 months, and suddenly mid-size AI labs and even well-funded startups can build purpose-built inference chips instead of renting general-purpose GPUs. Second, the feedback loop between AI and hardware accelerates. Better chips make better models. Better models design better chips. Cognichip is attempting to kickstart that virtuous cycle. If design timelines shrink from years to months, the pace of hardware innovation could start matching the pace of model innovation for the first time. Third, workforce dynamics shift. Cognichip says its platform acts like an expert engineering collaborator, not a replacement. But if a fraction of the engineering team can now produce the same output, that changes hiring, budgets, and competitive dynamics across the semiconductor industry. The company is already working with more than 30 semiconductor design firms, and early adopters report reduced design cycles and costs while maintaining manufacturing standards. But let's be honest about the risks. Cognichip has not publicly pointed to a single commercial chip designed end-to-end with its system. It has not named any of its customers. The 75% cost reduction and 50% timeline compression are company claims, not independently verified results. CEO Faraj Alai himself acknowledged last year that it would likely take a few years to build the model to ultimate performance. The competitive landscape is fierce. Synopsys and Cadence are entrenched incumbents already adding their own machine learning features, and well-funded startups like Chip Agents and Recursive are racing towards similar goals. Semiconductor manufacturing operates on extremely tight tolerances. Any design flaw typically surfaces only after an expensive fabrication run. Trusting AI-generated layouts in production is a massive leap of faith that the industry has not yet taken at scale. And the data problem is real. Chip design IP is closely guarded. Cognichip has had to build proprietary and synthetic datasets and create secure training protocols so partners can use the model without exposing sensitive designs. Whether that approach produces models as capable as those trained on truly comprehensive datasets remains an open question. So what should you do with this information right now? Here are 5 concrete actions. 1. If you work in semiconductor design or manage hardware development budgets, request a briefing from Cognichip or one of its competitors. Understand what AI-assisted design can and can't do today before your competitors figure it out first. 2. If you're at a company considering custom silicon and whether for AI inference, edge computing, or any specialized workload, revisit your build versus buy analysis. The economics of custom chip development may be shifting faster than your last feasibility study assumed. 3. Track the validation milestones. Watch for Cognichip or any competitor to announce a chip that has actually been taped out and fabricated using their AI platform. That is the real proof point, and it hasn't happened yet. 4. If you're an engineer in this space, start experimenting with AI-assisted EDA tools now. Cognichip hosted a hackathon at San Jose State where students designed RISC-V CPUs using its platform. The tools are reaching a usability threshold worth testing. 5. Evaluate your IP protection posture. As AI-powered design tools proliferate, the question of how proprietary design data gets used in training becomes critical. Understand what data you're sharing, how it's governed, and what secure training protocols look like. Here's the bottom line. Cognichip is selling a bold vision, AI designing the chips that power AI, backed by serious money and serious names, but not yet backed by a finished chip. The opportunity is enormous. The proof is still ahead. If you want to stay on top of how AI is reshaping the hardware that makes AI possible, subscribe to AI Blueprint. We'll be tracking every milestone as it happens.